Hey, looks like we are live again. Assalamu alaikum. Let's see what else. From where can I search this? Minin should be able to do this, right? No? Am I not live? Am I live? What's happening? I must be live, right? So if we go to Khan's official. Okay, I'm live, but apparently I don't get any invitations directly. Take it. Let's just share this on WhatsApp real quick. Live morning Python classes in the morning. Gotcha. Okay. What else can we do? This should do. Yeah. That should do. Screen dashboard. White screen dashboard. Okay. Okay. Now that we are live, I'm not getting any notifications. That's weird, isn't it? Yeah, that should be here, which is not the case. Should be getting a live stream info. Not. So we will find the official channel, and I have not subscribed. Which I have not subscribed. Which that's fine. Cool, eh? Cool. So let's not waste any more time. It's 7:30 already. So the idea is, so I'm already doing the digital marketing from Google. Let's see, Python certificate, and I want this Python certificate to be free. I have one option, that is free code camp. Okay, it's Python 3, Skillshare, okay, Skillshare, okay. And we have Python Audacity. Let's see. No. Skillshare is a beginner guide to Python programming, 7.5 hours. And do I get this degree program? It actually learn Python for long, 10 hours a week. Audacity. LinkedIn, I don't get this for free, I guess. Udemy for beginners, EDX, IBM. Really? Can I get a software from IBM? $39,000, okay. That's a lot of expensive shit. No, I'm not paying $39,000 for something that's free. Degree program. Let's see. Intermediate Python. Okay, no, I'm not an intermediate guy yet. Do I get 38,000 for 2 months access? 22,000. Fucking hell, that's expensive, bro. Oh, what happened here? No, I don't want 1 month of Skillshare. So Skillshare is how much? I need to sign up, which is monthly, I think. Step by step guide. No certifications here, I think. Yeah, no certifications. Okay, what do you have? We have one here certificate. We have certificates. EDX version क्या Udemy पे है क्या? Okay. That's nah. What else do we have? Okay, this is bullshit. Python, migrate learning, fundamentals of Python, for free. Just wait a minute. Certificate of completion would be from Great Learning. Free online course. Jesus, that's just stupid. Okay, Indian people just keep selling stuff, man. Just give me something that's of value without selling. Coursera, it's paid. Python Institute, paid. Upgrade, paid. Free online course with certification. Okay, upgrade पे है क्या? No, thank you. Oh, that's a bad UI. Upgrade free course page. Okay. I'm here for Python. Where do I search for Python directly? Jabber free courses. So zero cost learning management courses that choose online. Do I get a upgrade, right? Do I get a certificate for this? I don't know. I'm not sure. I don't think I'll get a certificate. Do I get a certificate? Certification, right? Certificate. Okay, free certificate. Okay, it's a free certificate. Okay, let's see. Upgrade learning graded online ensure that you get the best certificate by the learning course. You will receive the certificate for education that you will receive expenses. So I have one option that is upgrade. Okay, what else do we have? Anyone watching? Where is YouTube? Where is Hub's official? Where is the Howard Live thing? PythonInstitute.org. PCAP, okay? How can I get a Python for free? It can't be free. Audacity. Free Python certificate. Okay, it's a free course, right? Kegel. Yeah, I think I had one as well, Kegel. Python, machine learning, pandas, AI ethics, validation, and so Kaggle is a place where you can learn. Python that's pretty much it, yeah. Let's see. So I have to upgrade का है, then Python का है, right? Sorry, Kaggle का है. What else? Nano degree program, okay. This is an introduction to Python. It has an introduction to Python from Kaggle. There's no problems with Python. Nano degree certificate. God damn, okay. 22,000 rupees for a fucking nano degree on Udacity. That's a lot of money, okay. That's just stupid. What else do we have? God, it's half an hour. Reflecting Coursera, CRAD, Udemy. This better be good.
Google Career Certificates is about. They have various different fields in which they have launched different professional certificate website in the description, and you can move around and you can get access to this course, right? So as you can see, this is having multiple courses that I have told you before. So let's just go through these one by one. Our first course is a crash course on Python. In this course itself, you first of all learn about the basics of programming, right? The very basic stuff, right? What is a programming language? Why do we need programming languages? And the very basic fundamental concepts in the first week you'll be learning. Then you go to the second week in which you learn about expressions and variables, you learn about data types, you learn about functions, defining functions, using functions, returning values, as you can see. Then we go on to learn about conditionals, and in this you learn about comparison operators, you learn about if statements, else statements, elif statements, you learn about nesting, if else statements, and that is the second week. Third week you learn about recursion, and first of all you learn about loops, right? So you learn about while loops, you learn about for loops, very important things, learn about nesting, all of these loops as well. Then we go on to week 4, and in week 4 you learn about strings, you learn about lists, as well as they give you some other reading material that you can go through, right? So that's basically how the 5th week goes on. But this much practice is not enough. If you want to approach for your coding interviews, this might company interview questions with solutions available both in C++ and Java. Not only this, you also get more than 6 regular expressions. You'll be learning about managing files with Python. You click on the one thing is that how can you get the certificate, right? You might have this question. So if you go back, this is the complete professional certificate. If you click on the financial aid available, you can click on continue to the application. When you click on this, when you apply for the financial aid, they will ask you a couple of questions. Like for example, they will ask you, why do you want to apply for financial aid? What is your earning like? And personally, when I was getting started, I did not have any earning. I was pretty much not having enough funds to like buy courses and stuff. So I just applied for this. I just said my earning is 0. Why am I applying financial aid? Because I really need it. You can just write a long paragraph and you can get access to this course. It will take about 15 days to get the financial aid done. But once that happens, then you can get the course certificate as well. So what happens is that once you complete all the 5 or 6 courses that they have in this professional certificate, you will get a professional certificate from Google that you can use in your resume and stuff like that. But you don't need to worry about all of this if you just want to learn from these courses, which I think should be really the core focus of yours. Just click on enroll for free and just go down here. There's something called as audit the course, right? So you click on audit the course, and that is all that you need to do, and you are good to go with taking all of the classes and completing all the different assignments, as you can see. So that's all I have for you today.
Okay. Apparently I have to apply for financial aid because I just can't. You know what? Fine. We'll just start with free code camp or home, and then yeah, what do we have? Let's go with curriculum. QA, scientific computing, scientific computing, data analysis, and security, machine learning. Scientific computing, I don't know what that is. Data analysis should be it. Human security. Yeah, I think data analysis should do. Report practice at using expensive closed tools like Deliver, but recently Python, SQL, and other libraries have changed data analysis. Whatever data analysis with Python, learn fundamentals of data analysis with Python. How to read data from sources like CVs and SQL, how to use libraries like NP and pandas. So it doesn't have Python, yeah? Okay. Python for everybody, okay, and then time calculator, budget app, polygon heating, that's a lot of shit, okay. Let's just go to just do one more trial. Let's see what else can we find. 7:30. It's Python playlist. They provide certificates though. Let's see, okay. Oh god, okay. Do you have a channel? The we have a playlist apparently here which has no, I don't want to go through this. Oh, do you have like a complete tutorial thing? Okay.
Hello in Python. So let me show you.
I'm just looking for a,
There will be,
what do you call it, a certificate. I'm just hoping for the best here. Okay, okay. Let's see. Where is control F? Pennsylvania. Yeah, that should do. This is on class central, yeah. $200 for certificate. How much is $200? How much? $15,000. I'm not paying $15,000 for a fucking certificate. Crazy boy. It's not a small fee. You know what? That's just wasting my time at this point. Let's just start with Kaggle. You know. Yeah. Instead of doing it with Freeport Camp, I'll have one with Kaggle. Kaggle. How famous is Kaggle? Kaggle versus Freeport Camp. You'll have these you know what? I'm just gonna go with free code gambit is what I wanna do it. Let's see if they have videos. If they have videos, then I'm gonna go with the Python thing. Then you have your turn, okay. How do I? How do I? Okay, no. Cool. Then free code camp it is. Expand course and let's begin. Bismillahirrahmanirrahim. Oh god, do we have videos? No, I don't want to watch videos.
Hello everybody and welcome to Chapter 1 of Python for Everybody. I'm Charles Severance, I'm your instructor, and I welcome you to this class. The basic goal of this class is to teach everybody how to program, regardless of your background. You don't have to be a math whiz, you don't have to be a computer expert. To do some analysis to say me showing my age. and some of the things that, they can translate text, and that's because they've looked at a lot of information. So looking at...
Can I Google? Yeah. Hello? Oh, we've done some. Oh, okay. We can do again, right? Other than the language, elements of Python. Is it still a video? God damn it.
So now we're going to start learning the actual Python language. So what do we say? You can think of this as almost like writing a story. We're going to start with a basic vocabulary. We're going to talk a little bit about lines or sentences, and then we're going to start talking about how to put those...
Wait, do we even get a certificate? Yeah, we do, okay.
So now we're going to start learning the actual Python language. So what do we say? You can think of this as almost like writing a story. We're going to start with a basic vocabulary. We're going to talk a little bit about lines or sentences, and then we're going to start talking about how to put those sentences together to make a coherent paragraph, as it were. And you just have to accept the fact that when I start teaching you this stuff, it's not going to make sense for about 6 or 7 more chapters. And so just confused, holy mackerel, this is awesome. It makes sense in a big picture. Awesome, okay? And so this is a short story about how to count the words in Python. It's got a couple of paragraphs, and we are going to look at all of this stuff eventually. So we start with a set of reserved words. And what are reserved words? Well, they're words that Python expects when you use these words that they're going to mean exactly what Python expects to mean. And what it really means is you're not allowed to use them for any other purpose than the purpose that Python wants. It's for part of the contract. It's like when you have a dog and you go, what did you think of that television program? And the dog has no idea what you're saying. And then you say, do you want to wait until Saturday to go to the veterinarian? And the dog still doesn't know what you're saying. And then you go like, how would you like to take a walk? And then the dog goes, walk. I know what that means. And then hits the door, right? And so the way the dog sees you is blah, 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 walk, blah, 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 food, blah, 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 treat, blah, 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 walk. That's kind of how Python looks at these reserved words. When you say class, it goes class. Oh, I know what that means. Now, if I say zap, it's like, oh, zap's something that you get to decide, or it's maybe a variable name. So reserved words are simply words that when you use these words in Python, and there's only a few of them, like and or del, or if maybe, pass maybe, in. A lot of these, you won't end up using them. It's just these are reserved for Python and part of the Python vocabulary. This is Python vocabulary. Now, when we move from words to sentences, you see that Python is a series of lines. A Python program is a series of statements. They have an order because the computer wants to know what next, what next, what next. So what next is start at the beginning. So I already talked about an assignment statement that basically says x equals 2. This is not a mathematical statement. This is a directive to say, take this variable 2, this value 2, this constant 2, and stick it in a location in your memory. And remember that I asked you to name it x. X is a variable, something you made up. You chose that. And so but it's Python's job to remember it. So this says, go do whatever that x is. There's a 2 in there. Now pull that x back out, add 2 to it, which makes it 4, and stick it back in x. And so that makes this a 4. So x is a 4. And print x says, go look up that thing that was an x and print it out. And so these are like, each line has something to it. I'm using reserved word. Well, actually, that's a function, but it's a reserved word too. And so there's reserved words and all these things. And you combine these. There are operators. A plus is an operator. Equals is an operator. These things do things. And we'll learn all this stuff in time. So the basic building blocks of lines of Python.
Okay.
Now, as we take these lines of Python and build them up, we end up making paragraphs, programming in paragraphs. And so one of the things that it's important is I showed you how to do interactive Python. So you just type Python and you type a statement and statement and statement. Those get really tiring after about 3 or 4 lines of Python because you can start making mistakes and you have to start over. So the better thing to do is to, as your program gets a little larger, to write a script, put your Python instructions in a file, and then tell Python to read from the file and then run the script as it's entered in that file. We tend to name these files with .py, and I've got a series of videos that you can watch to figure out how this all works. Like I said, you can type interactively to Python, and it's a great way to experiment with Python, check to see if a statement does what you think it does, but script is the way, after we are past 1 or 2 lines of code, we write it in files and then run it separately. So there are a couple of basic patterns, and it's really important to understand each of these patterns, and like I said, we'll teach you these patterns separately, and then we'll combine them together. And when you combine them together, you say, oh, that's what a program is. So you have to suspend disbelief. We have a couple of different patterns. One is a sequence of steps. Do this, then do this, then do this. Conditional is like skipping something. Repeated does it over and over and over again. Computers are really good at repeating stuff, much better than people. People get tired going over and over doing the same thing. And then we have store and repeated steps as well. And so if we take a look at this, and we take a look at a Python program, this is a piece of code, this is a little script. If you type this into the code, take this code, Python code, into a file and ran it, it starts at the beginning, and it goes to the next line, and the next line, and the next line. And Python executes the scripts as you write them. So it says, stick a variable, find a place in your memory called x, stick 2 into that, okay, then go to the next one, print that out. So the program's producing output. Now go read x and add 2 to it, and stick it back in x, so x is 4, then print that. This side over here is called a flowchart. I'm not going to make you draw flowcharts. I'm only going to draw them a few times in ways that I think will help you. But you can think of it as Python, when it finishes something, it goes on to the next one, unless you tell it otherwise. Finishes this, goes on to the next one. Finishes this, goes on to the next one. Python finishes this, and now the program is all done. And so that's sequential steps. You just type them in, Python runs it. They're important, but sort of uninteresting, because you can only get so far, and you can't really make them intelligent because it's always going to do the next one. So the next thing we do is what are called conditional steps, and this is where it starts to get intelligent. I mean, where you are able to encode your brain into the computer. Like, oh, wait a sec, let's only do this step if something is true. And the syntax that we tend to use here is the reserved word if, okay? And so the if is like a fork in the road. You can go one way or you can go another way, and you're asking the question. So inside the if statement, right here, there is a question saying, is x less than 10? That resolves to a true or false. If it's less than 10, that's true. If it's greater than 10, it's false. And so then what we do is, if it's less than 10, we have this indented block of code. There's also this colon that tells us we're in the beginning of an indented block of code. And so what it basically says is, if this is true, run that code. If it's false, skip that code. So it can either run it or skip it, depending on this question that's being asked. Now, if you look at this code, it's pretty obvious what's going on. It comes down, x is 5. If x is less than 10, that's true. So it runs this code and prints out smaller. And then it comes back here, de-indents. The next basic sequential, this ends up being kind of a block. If x is greater than 20, if x is greater than 20, oh, come back. If x is greater than 20, this turns out to be false because x is 5, and so it skips this. So the bigger never comes out, and then it continues on and prints fini. Oops, that's a typographic error, make that a lowercase print, and then prints fini. So it comes in, runs this, skips this, and then finishes. Okay? So here is the last one we'll talk about, the repeated steps. We'll get back to store and retrieve later, but for now we're just going to talk about 3 of the 4. This is another program, and the key is that we're going to use this same choice where we're going to go in, but then we're going to run for a while, and then we'll have an exit condition where we get out. So this is a repeated over and over and over and over again, and this is the essence of how we make computers do things that are seemingly difficult. Well, they're more naturally difficult for people, okay? And so how do we encode this notion that we want to do something for, not forever, but for a while? How do we encode that notion? And so we do it in this way. So we have our statement, sequentially go to this while. While is a keyword, and it's asking another question that's a true-false question. Is n greater than 0? I read this as long as n remains greater than 0, keep doing this indented block. And you have a colon at the end, and then you have 2 lines of code that's indented, so that tells us what the loop is, and then this is now de-indented. And so it comes in, and if this is true, it runs these 2 lines. Prints out n is 5, and then it says n equals n minus 1, which makes n be 4. It goes back up, and it goes up and it asks this question again. Is n greater than 0? If it is, continue on, and prints 4, and then subtracts it, and it does that. 4, 3, 2, and prints out 1. Then it comes up, and now, after this, n is now 0, n is now 0, and n is no longer greater than 0, so it takes sort of the exit ramp and goes down here. So it takes the exit ramp and goes to here and runs the next line. Now, we're going to cover all this again. So I'm just trying to give you the big picture. Next couple chapters, we're going to hit all these things again, and we're going to hit them in much more detail with a lot better information. This is now sort of like combining these. And again, I don't want you to really know this stuff. You will know this in a couple of weeks. You will see this program again. But this shows you how we combine those patterns of repeated, sequential, and conditional together. So this is a bit of sequential code, comes in here, runs this, which happens, asks for a file name, then it opens the file, it creates a data structure called a dictionary. This is all sequential. Now the 4 is another form of loops, so this has been a loop for a while, and then this is within a loop, we can even have 2 indents, and that's another loop. So these are like repeated, and then it goes down to the next sequential bit, then it does this, here's another loop, it's going to run, and then here's a conditional it's going to run, and then when it's all done, we print out the last thing. And this is, of course, is the program that does it figures out the most common word and prints that most common word out. And so this is a Python short story. It reads some data, it reads the name of a file, it opens that file, it talks about how to make a histogram, and then it looks through for the most common word. So don't worry too much about this. Over the next couple of weeks, we'll fill in the pieces so that you absolutely understand every single line of this code. So, just a quick overview of Chapter 1. Stick with us. You realize it will be Chapter 7 before this makes too much sense. You really have to trust that you are learning important things, and that it all makes sense when we bring it together like in Chapter 7 in a few weeks. Hello, and welcome to Chapter 2. Now we're going to continue to talk about the building blocks of Python, variables, constants, statements, expressions, etc. The first thing we have to talk about is constants. These are just things we call constants because they don't change. They're numbers, strings, etc. And we use them to sort of start calculations, or if something is greater than 40 hours, we're going to do something. So 40 is the constant in that situation. So we have 123, we have 98.6, we have hello world, which is a string by enclosing it in quotes. We pass each of these things to the print function, and aside respect to the print function is that we see the output. So print 123, prints out 123, print 98.6, prints it out. So these are just really the syntax of constants, and without constants we can't write really much of anything. The other sort of foundational notion of any programming language are the reserved words. And like I said before, reserved words are these special words where Python is listening for them, and there are very special meanings. So when Python sees if, it's not just any other word, it means how Python implements conditional execution. Variables are the third building block, and that is a way that you can ask Python to allocate a piece of memory and then give it a name. And you can put stuff in that. Sometimes you just put one value. Later we'll see, when we do collections in chapters 8 and 9, we will see that more than one value can be put into a variable. And the variable, how we control the variable is through the assignment statement. And as I said before, it's important to think of the assignment statement as having an arrow to it. So this is not saying x for all time is the same as 12.2. What it's saying is take 12.2, find some memory in your computer there, Mr. Python, give it a label x, we get to choose the x. That's the variable part. We chose it, right? And then stick 12 in it. And then the same is true for 14. We'll find another spot, name it y, and then put a 14 in there. So think of this as an arrow every time you see that equality, the assignment in an assignment statement. Now, these variables hold one value. So now if we have these three statements, these two, and then the third one executes, it says put 100 into x, but that wipes out the old value of 12.2, and it rewrites it with 100. And so we can change the variables. That's another reason that we call them variable. There are some names. Now, there are some rules for making variable names. You can start with a letter or an underscore. We tend not to, as normal programmers use underscore, we tend to reserve those for variables that we use to communicate with Python itself. So when we're making up a variable, we tend not to use underscores as a first character. You can have letters and numbers and underscores after the first character, and they're case sensitive, but it's really a bad idea to use case as the only differentiator. So in this case, spam, eggs, spam23, and underscore speed are all totally legit. We would probably not use this one unless we were actually doing it because Python told us to use that variable. 23 spam starts with a number, pound sign starts and dot is not a legitimate variable character. And spam, capital spam, and all cap spam are different, but this is not something that you want to sort of depend on too much. So that's just the rule names. We tend to start them with a letter and then use letters, numbers, and underscores. Underscores other than the first character are generally pretty common, and you'll see those used a lot. Now, when we're choosing variable names, one of the things about variables is we get to choose the name. We get to choose the name X, choose the name Y. And so sometimes we like them short, but sometimes we want them descriptive. And the notion that of making variables descriptive is often confusing to beginning students. Sometimes it's really helpful to, if you're going to have a line of text and you name the variable line, that's great because the next person reading your program says, oh, that must be the line of text. Whereas it also can become misleading that the name of a variable somehow has meaning. So sometimes we're writing singular variables and plural variables, like friend and friends. You know, like is plural? Does Python know about singular and plural? And the answer is no. So sometimes we pick variables that make no sense. Sometimes we pick variables that make a lot of sense. This is just something that you as a beginning programmer are going to have to understand, that we can pick anything we want. And so you'll see, I'll try to call attention to this in the first few lectures as we go through. So here's a bit of code with an assignment statement, two assignment statements, a multiplication, and a print statement. And you can say, what is this doing? Now, Python is perfectly happy with this code because it assigns it in there. You have said, please go give me this as a label. And then we assign two variables. And then we're carefully pulling these two variables back out, multiplying them together and sticking them into yet another variable, and then printing that variable out. That seems like, we can figure out what it is. You just have to look really carefully. And a single character mistake, and Python is going to be, pretty unhappy. Okay? So that's one way to write this program. It's hard, though, because any of those characters are one variable and they're random stuff. It's not very friendly to anyone who might read your program. Now this looks a little friendlier. It's the same program because Python just wants a correspondence. You pick A, you pick B, and you pick C, and it's really much easier for us to see what's going on. And so this is, in a way, going from here to here is much friendlier, but we can be even friendlier if we pick mnemonic variable names. So this is not mnemonic, this is short and convenient, this is long and inconvenient. Python is happy with any of these. Here, on the other hand, is another version of the exact same program. And now you think to yourself, oh yeah, now I get it. 35 is the number of hours, $12.50 is the rate, and then we're going to multiply the hours and the rate and come up with the pay, and we're putting out the pay. Now whoever wrote this program is helping us greatly understand what's going on, and that's good. Choosing variable names. But Python, again, all three of these are the same to Python. Choosing variable names in a way that help your reader understand what's going on is a great thing. The problem is, the danger is, if you read this and you think that somehow Python understands payroll, that if you name a variable hours, that Python knows what hours means. The answer is, Python really doesn't care what you name a variable as long as what you name it, you use it, right? And so you got to be careful. And so you'll see, when I write my code in these first few weeks, first few lectures, I will sometimes write it with gibberish. I'll sometimes write it with extremely short but meaningless variable names, and sometimes I'll use meaningful variable names, and I'll call your attention to it, and it will get you. You'll start, when you look at this third kind, it has meaningful variables or mnemonic variable names, you'll just instinctively want to give Python more intelligence than it sort of deserves. I guess that's probably the best way to say that. So we've talked about constants, we've talked about reserved words, we've talked about variables. And so here we have a sentence, like we've already done some of these things, where we set x equals 2, we retrieve the old value of x and add 2 to it, so that becomes 4, and then we print 4 out. Print is a function that's built in, and we pass in whatever we want to print out. So this parentheses is part of a function call. Okay, so an assignment statement, you have to really get your head around the notion that it has this arrow nature, and that it evaluates this entire right-hand side before we change the left-hand side. And so you can think of this sort of as at time step 1 it does this, and then at time step 2 it does the copy. And that's how you can have something like x on both sides of an assignment statement. And so if, for example, we have x and x has 0.6 in it, what happens is that it sort of ignores this part right here and evaluates the expression. So it pulls the 0.6, everywhere x appears, it pulls 0.6 out, then it starts running these calculations, and then it has the new value. After all the calculations are done, then and only then is it going to put that back into x. And so it sort of takes that and puts it back into x, and then wipes out the old value. At this point, this has all been taken care of, and it's been reduced down to this 0.93, and so that is what's put in as the new value. So up next, we'll talk a little bit more about making more complex expressions.
Okay, stop. Oh yeah, just 9 minutes left. What is the symbol used in the assignment statement? Assignment. I know at least enough. I don't have to go through all this. Okay.
So welcome back. We're now going to talk about expressions. Expressions are a little more complex calculations that we can sort of do on the right-hand side of an assignment statement. So one of the things about expressions is operators. And the operators in computer programming are often very much the same as the mathematical operators, but we don't have all the fancy characters that we have in mathematics, and so we have to choose what's on the keyboard. And then we really go back to the 1960s and 1970s, and we use what was on the keyboard in the 1960s and the 1970s to make these operators. So plus is addition, minus is subtraction, we don't have a times sign or a dot in the middle, so we use the asterisk as multiplication. Division, we can't put two things over top of each other, so we use slash for division, raising to the power, because it didn't have little characters back then, is star star, which is raising to the power, and then remainder. Remainder is when you do integer division, it's also called the modulo operator, it's the remainder, not quotient. I've got a picture of that coming up. So here's a whole series of little examples of this, right? So we've already seen, the plus, x equals x plus 1. Keep remembering that these assignments are arrows, basically. Arrow, they have a direction. Multiplication, 440 times 12. Dividing this by, that's division, over 1,000, 5.28. Here we're going to put 23 into JJ, and then we're doing modulo. So that says, take 23 divided by 5 and divvy back the remainder and put it in KK. So this is the expression that evaluates like this. Take 23, divide 5 into 23, 4, remainder 3. The 3 is what comes back up here. Okay, and so that is the remainder. It's also called modulo operator. It turns out that for things like picking a random number and then taking the modulo of 52 is a way to pick a card randomly. So this modulo operator is actually, especially in games and other things, super useful. So that's the various operators. It's important to know which of these operators goes first. It's called operator precedence. Now normally we put parentheses in, so if I put the parentheses in here, I'd say this goes first, parentheses, then this goes first. Oh, actually not that one. Oops, got that one wrong. This happens first, this happens, then this happens. Okay, and so, but it's important for us to be able to know, if there were no parentheses, the order in which these things will happen. So the way things work in terms of operator precedence is parentheses are the most important thing, followed by raising to the power, all else being equal. Multiplication and division are all both equal, and then addition, and then within it's adding left to right. So let's see an example of how this works. And so if we take 1 plus 2 to raise to the 3 power, divided by 4 times 5, and we print out what comes out of this. So the way I did this when I was taking exams back many, many years ago when I was first in computer science is I write it all down and I look for the highest precedence thing. Now parentheses will make this easy, but exponentiation is the first one. So that means we're going to take this, and that's going to be 8, 2 to the 3rd power, 2 times 2 times 2, 2 cubed is 8. Then what I would do is I rewrite the whole thing with the 8 there, and I look across, and I'm looking for multiplications, because the power's been done, the multiplication is what I'm looking for next. And then there is both multiplication and division. They're equal, they're at the same level. And so what happens is they're done left to right. 8 divided by 4 happens before 4 times 5. And so the fact that it's not 4 times 5, but instead 8 times 4 is because of the left to right rule. So then this gets rewritten to be 2, 1 plus 2 times 5, and this one, multiplication is the top one, so that does this next, 2 times 5 becomes 10, I rewrite it again, and then 1 plus 10, addition is the lowest thing, and that's how we end up with 11. And so that's how I would do these problems if I ever saw the problem on an exam. And it's a fun problem to put on exams because there is one and only one answer, and every programming class has usually at least one slide about this stuff. So like I said, the rules go top to bottom, parentheses, power, multiplication, addition, and then left to right within it. So we talked about variables and computing values to put inside variables, but the one thing you kind of also maybe you noticed it as we go by is we have different kinds of data. We call it type. Is this a type integer? Is this a type floating point number? Is it a type string? What is going on here? And Python is pretty smart about various kinds of types of data. And so we're adding 1 plus 4 here, and Python knows as it looks at this that that's an integer and that's an integer, and we'll add it together and make it an integer. So that thing is an integer. We can also use this plus to concatenate two strings. This is hello blank plus there, and plus looks here says, oh, that's a string and that's a string. So I know what to do with strings. I will concatenate those two things together so it becomes another string that gets assigned into E, and it's hello space there. The plus doesn't add the space. I added the space by putting it right there. And so these operators are kind of smart in that they kind of know what they're dealing with, and sometimes they will do one thing or another depending on the kinds of values, variables, or constants that they're working with. And so sometimes type can get us in trouble. So here we have E, which is hello there because we concatenated these two strings together, and now we're adding 1. And the problem now is that it looks on one side and says that's a string and that's a number and says I don't know how to do that. This is another one of those annoying errors that you think that somehow Python doesn't like you, but it just is confused. If you look at these things, traceback. Traceback always means I quit. It means I stopped, I ran, I'm quitting now because I don't want to go any farther because I become confused. So your program stops running and you say here's where I stopped running. Because we're typing interactively, it's always line 1 here. Type it, but if you read carefully and you don't get too stuck on too much stuff, line 1 that tells us something in module type error can't convert int object to str implicitly. So that's an integer right there and that's a string, and that's what it's complaining about, that little bit right there. If Python is so grumpy about types, then we should be able to ask it about types. So it turns out that there is, inside Python, a built-in function called type, T-Y-P-E. So we can pass into type. So the syntax is calling a built-in function named type, parenthesis is the parameter that we're passing to it. We're saying, hey, hello, tell me something about the type of the variable E. And so this is a function, the parentheses are part of the function call, and it says, oh, that would be of class string. And then we can pass in a constant and says, hey, what about hello? The string hello, it's like, oh, that's a string too. What about a 1? Well, that's an integer. And so we are asking Python through the type function what the type of either a variable or a constant is. And there are even several types of numbers, and we'll even see booleans and others later. Like 1 with no decimal, that's an integer number. 98.6 with a decimal, that's a floating point number. And so, constants can be both integer and floating point. And I'm just asking over and over and over again, what is the type of what's in XXX, what's the type of what's in temp, and what's the type of the constant 1, what's the type of 1.0. You can also use a set of built-in functions like float and int to convert from one to another. And so this basically says, I want to convert, let's go back. I want to convert 99 to a floating point number. So this is a function and it's participating in this plus, but before it can finish the plus, it turns this into a 99.0. The difference between 99 is an integer and 99.0 is that it's a floating point number, and that actually turns this computation as it looks to the left and looks to the right, says, oh, I've got a floating point number on one side, integer on the other side, and so I'm going to make my calculation overall be a floating point calculation. I can also pass into the float function. I can say, take this variable I, which has 42, also an integer, and then give me back a floating point. So that'll be 42.0, pass it into f, we print it out, and it is indeed 42.0, and it's a float. And so it knows the type and value in any variable. This is an integer, a value 42. This is a float, a value 42.0. Integer division in Python 2 was kind of weird, and it was actually one of the big things that they changed between Python 2 and Python 3. It's a Python 3 course, so we're not worried about that too much. What's nice about integer division in Python 3 is it always produces a floating point result. And that means that Python 3's division is more predictable, and it works more like a calculator. So in this case, I mean, you can go back and look at my Python 2 lectures and see how crazy it was in Python 2. 10 divided by 2 is 5.0. And the weird thing here is these are both integers, but the division forces the result of the calculation to be a floating point number. And this, 10 over 2 could be 5, but 9 over 2 is 4.5. And so that is accurate. In old Python 2, that would give us back 4, which is completely unpredictable and weird. The same with 99 over 100. As you would expect, if this were a calculator, you get 0.99. Actually, what you get in Python 2 is 0, because it would round it down. It doesn't round at all, it truncates it. So 99 over 100 is 0.99, and then it truncates it to 0. That's Python 2. We're not talking about Python 2. There's a good reason we're not talking about Python 2. Welcome to Python 3. Of course, if there are a floating point on either side, the result is still a floating point, and the result is still a floating point. So integer division produces a floating result in Python 3.0, not in Python 2.0. That is an improvement in Python 3.0. And that's why we're recording these lectures. I have a whole great set of lectures about Python 2, and now I'm going to have a great set of lectures about Python 3. Welcome to Python 3. Okay, so we've been talking about converting from integer to floating point, but you can also convert from string to integer or string to floating point. And so here we start out with a little string value. Now it only works for strings that are made of digits. So quote 1, 2, 3 quote is not an integer. It is a 3-character string that has 1, 2, 3 as the characters in that string, which is very different than 123. We say, what is the type of this? It's a string. We say, let's add 1 to it. And it says can't convert into string, so that blows up, right? Because this is a string. It looks to both sides. String plus an integer, not good, okay? But we can convert this. We can call the int function, which is like the float function, and pass a string in. So it says, hey, take this and turn it into an integer. So take the input of sval, which is the string 1, 2, 3, and give me back an integer representation of that, which is going to be 123. So we say, what kind of thing do we get back? Well, we got back an integer. We can now add 1 to it and get 124. And so you have to manage the type of things, and you can convert from one type to another. Now, int is not magic. If you send something into it, a string that doesn't consist of digits, then you're end up with another error. Invalid literal for integer with base 10, blah, 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 blah. So it's really complaining. It says, I want these to be numbers here, and you just gave me letters, so that's going to cause this to fail. Another thing that we're going to do with variables is, just like the print function takes something, a list of things, in this case, a string, comma, a variable, and then prints some output in the program, the opposite of that is input. Actually, input generally happens before output. Input is a built-in function, and we pass to it a prompt, a string of text that's going to be printed out for the user, and then it stops and waits. So it says, who are you? And then right here it just sits, waiting for us to type something. So we type blah, 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 and then hit the enter key, right? We hit the enter key, and then this text ends up in this variable. So this is an assignment statement that Chuck is the result of the input call, gets copied into the NAM variable. So let's do that again. It's evaluating assignment statement. Remember, it's kind of this way, or you can think of it as do this right side first. It writes this out, writes that out, then it waits, wait, until we hit the enter, and takes this Chuck, and that becomes the result of this input, which is then assigned into NAM. Now then we go sequentially to the next line. It prints out welcome, comma, NA, contents of the variable NAM. Now this one, this comma here, actually does put the space in here automatically, so it says welcome space Chuck. So it pulls there's no space in Chuck, just CHUCK. And so print can take more than one thing separated by commas. As a matter of fact, print can have, a whole bunch, oops, come back. Print can have comma, parentheses, as many as you like. Everything you see up to now is kind of one thing to print, but that doesn't mean the print only can do one thing. So I've talked about variables, we talked about constants, we talked about input, we talked about output, and now it's time to write our first meaningful program. And
oh wait. Hi. Okay.
So this program has to do with those of you who have traveled internationally. If you travel to the United States and you travel outside the United States, you notice that there is an elevator convention that is different inside the United States. In the United States, to walk in the ground floor in the elevator, that's 1. And if you walk in the ground floor in Europe or many other places in the world, then the elevator is 0. So we have written a small app that we're going to put on the App Store and get wealthy with, what's called Elevator Floor Conversion App. And it's going to ask us, we're in Europe and we're lost, and you say, well, what floor would this be if I was in the United States of America? And so here's, we have to read the floor that we are at in Europe, and then we're going to convert it to a US floor and we're going to print it out. This is very silly, but it is a pure essential program that has input, does some kind of task on that input, and then produces some output, which is useful for some value of useful, okay? So let's take a look at how we combine everything that we learned in this lecture, input, processing, and output. It's a 3-line program, but it's sort of the beginning of something that programs do. Okay, you're going to do lots of programs. We type in 0, that comes back here, and then do a string. So quote, and on this right-hand side, we convert that string variable to an integer, so that becomes the integer 0. We add 1 to it, and then that becomes 1. It doesn't know anything about elevators, it's just I picked a variable that was quite friendly. And so at this point, USF has the United States floor that's equivalent to the European floor, and then I just fall down and I do a print statement. Print out US floor, comma, that's the space right here, and then whatever the contents of the US floor variable is. And you could see that I could write this on 4, and it would say 3. I could write this and say 7, and it would say 6. This is an amazing program. It converts floors in a European numbering scheme. Wait, actually no, I got that wrong. Hang on, let me clear this. I wasn't thinking clearly. I could type in 4, and it would give me back 5. I could type in 6, and it would give me back 7. See, I'm confused. Haven't been in Europe in a couple of months, and so I forgot all about the floors. But that's the idea. Now, this is a super simple program, not super useful, but you get the idea that we're going to pull some data in, we're going to do some intelligent thing. Soon this will be hundreds of lines of code instead of one line of code, and then we're going to present the results to our user. Now, another element of most any programming language is what's called a comment. A comment is a way for you to put in a program file some text that's to be ignored by Python or C or whatever language we happen to be using. In Python, comments start with a pound sign. So what you can do is put a pound sign anywhere in a line, and then after the pound sign, Python ignores everything after that pound sign. It can be the first character. So here's our recurring concept that we talk a lot about. We're not going to cover this. Remember what to get back to this code. But what we've done here, paragraph, is count the word and sign in, find the most common word, and then I'm all done. I print the stuff out, right? And so, and they're nice. And you don't have to use any particularly weird syntax or variable name conventions. You put a pound sign in, and you can write anything you want from that form. And how expressions work and the various operators converting between different types, printing, input, output, and comments. So that just kind of gets us sentences. And coming up next, we'll talk about conditional execution, where we're really starting to move up to paragraphs. So see you in a bit.
Okay. What will print out of running this code? Width 15, height 12, print height divided by 3, 4.0. Yay. Is that an SQL?
So now we're going to, so now we have a record. So it's kind of like get rid of data. And so I'm going to, the next thing we're update and delete, CRUD. And we've done all those things, except we did.
Okay, good. Set up a conversion with the, okay. I should do it, yeah. 804. What is... Oh, that we're done with this. We can go back now. Bye. 500. Thank you for watching, whoever saw this.